Hi guys, welcome to Netgate Chemistry. So in this video of quantum chemistry, we are going to discuss about the commutator operator. So if we talk about the commutator operators, then mathematically it is represented by brackets. So brackets can be square brackets also, and these type of curvy brackets also. So what happens if we have two operators, A operator and B operator, in brackets, then that is said to be having commutator operator. So if this value is equals to AB minus BA, so this is how we can open this bracket. So if this is given to us, that is we have two operators A and B operator, and we have to open that commutator bracket, then it will be opened like this, that is AB minus BA. So and these two operators, A operator and B operators, these two operators will commute only if commutation of A and B equals to 0. Okay, this is the condition for two operators to commute. Okay, if commutation of A and B comes out to be 0, then we are going to say that A and B, both these operators, will commute. Now that means what? AB minus BA will be equal to 0, because commutator bracket when gets opened, it is opened as AB minus BA. So this implies that AB will be equal to BA. This is the condition for commutation. Now if in exam question is given as you have to, and in that question you have to open this bracket, this is also bracket for commutator operator. So if you have to open this bracket, it can be written as this or this or this, all are same. Okay, these are all commutator brackets. If in the question they have given that you have to open these brackets, and beneath these brackets they have given the negative sign, that means what? That means what you have to do is, it will be equal to AB minus BA, right? If underneath these brackets, beneath these brackets, negative sign is given, that means it is AB minus BA, or you can say simple AB commutator if negative sign is given. But if positive sign is given, that is if they have given question like this, and underneath these brackets they have positive sign, plus sign, that means that this will be equal to AB plus BA. Okay, now it will not be AB minus BA, it will be AB plus BA. So I am putting this under a box. So this is something which you should remember. If underneath the brackets it's plus, then in the formula itself it will be plus. If underneath the brackets it's minus, then in the formula itself it will be minus. This is how you can learn. So this is the property of anti-commutation. So if this is the condition, then operators are said to anti-commute, right? This was the condition for commutation, right? This was the condition for commutation, and this is the condition for anti-commutation. Okay, now we are going to understand one more thing. Suppose we are solving the commutation of A and B, two operators A and B, then it will be equal to AB minus BA, that we know. Now what if I take negative sign out of this? So what will happen? Negative, it will change into BA minus AB, because I have taken out the negative sign. Now if again I'm going to take negative sign out, what will happen? It will be again become AB minus BA, right? So A and B commutation will become equal to minus of minus, and this is what, this is commutation of A and B, right? Now if I'm again going to solve this same equation, that is commutation of A and B giving minus of minus commutation of A and B, same as this one, then what we are going to do is it will be minus of minus commutation of A and B will be AB minus BA. This is the formula which we know. Now it can be written as minus of, if I take this negative sign inside this bracket, then it will become BA minus AB, and this is what, minus of, this is commutation of BA. So here what we are getting is AB is coming to be equal to minus of BA. Now if you remember that we have studied symmetric and anti-symmetric functions, if function is equals to minus of fx, then it is said to be what? It is said to be symmetric. And if f of x is equals to minus of f of minus x, then the function is said to be anti-symmetric. Now here what you can observe is that here AB is coming out to be negative of negative A and B commutation. Here what we are getting is A and B, they commute and give minus of B and A. So out of all these observations, what I can conclude is that commutator operators are anti-symmetric in nature. So what I mean by saying all these things is that if you are not able to understand this part and this part, then you need not understand this part. You just have to understand that commutator operators are anti-symmetric in nature. This is the main thing which you have to understand from here. If you're not able to understand these derivations, then there is no need, there is literally no need to go for these derivations. You just have to remember that commutator operators are anti-symmetric in nature. So now we'll try and solve some of the questions based on commutator operators, and based on our results we are going to have some of the common results. So first we are going to solve a question in which we have to find out the value for the commutator of x and d by dx. So we have to solve this commutator. Now what we have to do is, we know that if we want to open this commutator bracket, then commutation of a and b opens as ab minus ba. So what we have to do is, first we have to take any arbitrary function, because operator itself has no meaning, so we have to operate this over any function. So we are going to operate this on a function psi, right? Now what it will be after opening the bracket, that will be x d by dx, psi is a function of x, suppose d by dx of psi x minus d by dx of x into psi x, right? ab minus ba. If you are not able to understand this step, then I can write down one more step before this step. Then what it will be, it will be, see, a and b, commutation of a and b will be ab minus ba. So how you are going to open this, it will be, suppose this is a and this is b, so it will be a b minus b a whole multiplied by psi x, right? Now if we take psi x inside this bracket, then what it will be, it will be x into d by dx of psi x, this one, minus d by dx of x into psi x, this one. Okay, so from here you can go here, or if you are good with your basics, then you can go here also. Now after this step, what we have to do is, it will be x into d by dx of psi x minus d by dx of x into psi x. So we have studied a formula for d by dx of u into v. So it says u dv by dx plus v du by dx. Right, this is the formula which we are going to use. First function differentiation of second plus second function differentiation of first. So this is what we are going to do. So here u is this and v is this. So what we have to do is, first I'll apply the bracket. Now first function as it is, differentiation of second plus second function as it is, differentiation of first function. Right, what I have done is, this part is same. Now minus, we have to do d by dx of these two functions. So what we have used this formula, that is first function differentiation of second plus second differentiation of first function. So here we have first function as x and second function as psi x. So we have applied this formula. Now if I open this bracket, it will be this dx by dx will be cancelled out, right? So we will be left with this. So these two will cancel out and we will be left with this one, minus psi x, or you can write it as minus 1 into psi x, right? So now here what we can see is, these two operators are not commuting, because for commutation these two should be, ab minus ba should be equal to 0, and here it is not coming out to be 0, right? So it is not commuting. So if they're asking whether they commute or not, the answer will be no, they are not commuting with each other. Now we'll move on to, or maybe we will solve some more questions in the next video, right? So in the next video we will solve some of the questions, and based on the results we are going to find out some of the common solutions. So that is going to make our calculation and numerical part very easy. So far that's it for this video. Thank you so much for watching.